Hello everyone, my name is José Gomes. I'm part of the research group Voxar Labs. Today I will present the work called Comparison of RGB-D sensors for 3D reconstruction. The concept of our work is related to 3D reconstruction, which is the process of capturing the shape and appearance of the real object. One way to capture that information is through RGB-D sensors. The main objective is to analyze how well 10 RGB-D sensors perform when applied to a 3D reconstruction task. The sensors were chosen because they are the most popular sensors in the articles reviewed in the State of Art section. The 10 sensors are Kinect V1, Kinect V2, ASUS Action Pro Live, Orbbec Astra Pro, Realsense ZR300, Realsense 435, Realsense R200, Realsense SR300, and Realsense F200. We decided to focus on technology derived from the classification light waves. The comparison between the sensors was performed with the help of the e.Do, a robotic arm usually applied for educational purposes. We used the robotic arm at 25% of the maximum speed to make sure that it would be slow enough to not interfere in the 3D reconstruction. The recording of the movement made by e.Do allowed us to have a ground truth to the trajectory performed. Now I will explain how the evaluation of the sensor was developed. The first phase was the capture of the environment. Because the coronavirus epidemic, access to the research lab and other common areas has been impaired, limiting the possible environments to be captured. The chosen environment was a child bedroom. The e.Do was placed in the center of the room, which was filled with different objects in different positions and with different textures. Here we can see the captured environment from 4 different points of view. The second phase was the data capture that was divided into 2 phases. Here we have a sample of the data captured by the sensors. The first phase is related to the 3 paths proposed that each sensor must perform through the same movement. The 3 paths can be seen here. They are very similar, but they are notable difference. The first is a simple 360-degree turn. The second is a wave movement, which performs the same movement as the first, but vary the coordinate of the z-axis. The third focuses on changing the distance to objects to assess how it affects the reconstruction. The second phase of the data capture is related to the setup of the RTAB-map. The capture of the sensor's data was done through the RTAB-map data recorder module. Unfortunately, some of the sensors, such as Astra Pro, could not have the data recorded via RTAB-map module available online. To overcome this problem, RTAB-map was recompiled and support for the device was added. The third phase of the methodology was the comparison of the 3D reconstruction, following 2 analyses, a quantitative one and a qualitative one. The first is a quantitative result. The initial result is about the camera trajectory. Each trajectory saved for each sensor was compared with the ground truth. The error is calculated based on trajectory points sampled every half second. Here we have the total of points saved for each path. Here we have quantitative results about the mean error for all the 3 paths and for each sensor. Now we start to talk about the qualitative results. For path 1, all sensors were capable of performing a full 360 reconstruction except the oldest Realsense models, F200, R200, SR300, and ZR300. For path 2, all sensors are capable to perform a 3D reconstruction, except this time no Realsense model was able to do it. For path 3, all sensors were capable of performing a full 3D reconstruction, except this time the Realsense models F200 and SR300 and R200. Now we start to talk about the reconstruction analysis. Analyze the results. Realsense R200, SR300 were always among the worst results. One possible reason for that may be the short range of this camera. About the pose analysis. For Path 1, Astra Pro, Realsense D435, Kinect V2 and Action presented a path with a mean error lower than the mean of the error. For Path 2, Astra Pro, Kinect V1 and Kinect V2 and Action presented a mean error lower than the mean of the error. For Path 3, Astra Pro, Realsense 435, Kinect V1, Realsense ZR300 performed with more points than the mean. So we have the conclusion of the work. This work performed a comparison of 10 RGB-D sensors regarding the ability to generate data for 3D reconstruction application. The worst result pertaining to the Realsense models. Considering the path error for all three paths, Astra Pro, Action, Kinect V2, and Kinect V1 were the sensors with the best results in descending order. Both Astra versions and the Action, together with the Realsense 435, are a good choice when performing a large-scale reconstruction using mobile platforms. To finish, we made available all data regarding the 10 RGB-D capture. This comprises over 19.2 GB of data, considering both RGB-D and depth stream for all cameras. Thank you for your time.